All right, guys, welcome to my remote classroom. We're here in my little basement office that I've turned into a classroom. I've got my nice little whiteboard back here, and we're in week 2 now. This week is all about the skeletal system. Actually, the next 2 weeks are about skeletal system. This week is all about the physiology of bone, and then next week is mainly learning the bones. Okay, so you should go through the resources that are on Blackboard. You know, the bone functions, bone structure, microscopic structure. Make sure you can identify all those things either from diagrams or from descriptions of their function. Okay. Just a side note, what you should be doing with this class is starting out with the objectives for each unit that are posted. Those objectives drive the bus. So don't go any deeper into detail as you're going through your book and your lab manual than the objectives say. Secondly, that lab manual is golden. It's golden. The textbook is awesome too. It really explains things very well. But as far as practical things that you can do to practice so that you'll, you know, be actually doing instead of just reading. The lab manual is phenomenal, especially the pre-lab activities. So I've assigned things in the syllabus there. Those are my suggestions to you. These would be good things to do that would help you prepare for our test and for our lab practical when that comes up. By all means, that is not the only thing you could do, right? I would recommend doing a lot more than that. But again, be careful that you're not doing things that require more detail than what the course objectives for each unit include. Okay, so today I want to talk a little bit about the different cells that make up bone. And we already saw, if you've looked at the bone structure already, in the microscopic structure, that there are these things called osteocytes, right? Osteocyte, bone cell. Okay, so there's 3 types of bone cells, though. Osteocyte is only one of them. I'm trying to find my markers here. Okay, so you have osteocytes, and those are mature bone cells. Mature bone cells. Osteoblasts, right? And osteoclast. And if you looked at the presentations, I do talk about these, but I want to give you a little bit more about them because they're really critical to the physiology of bone. Okay, so osteoblasts are builders. Osteoclasts are resorbers or eroders. So basically, your bone is a very dynamic tissue. It's being replaced all the time. So you've got a set of cells, the osteoclasts, that are eroding away and taking away bone, and you also have bone building cells called osteoblasts. They're replacing it. And from what we learned in the histology part last week, we learned that connective tissues, which bone is, they are made up of cells that produce a matrix, right? And it's the matrix that does the job of the connective tissue. So the matrix of bone, which is primarily made out of collagen and calcium salts, collagen makes it strong, the calcium makes it rigid and hard, right? But that gives bone its characteristics of being so supportive and all that. Okay, that matrix is produced by osteoblasts. They're the matrix builders. And see, they're sort of round cells, and they just start putting down matrix all around them. Okay. And before you know it, it's kind of like when you want to paint a floor, you never want to end up in a corner somewhere, right? Or you're stuck. Well, this is what happens to the osteoblast. So the osteoblasts are laying down matrix, laying down matrix, laying down, and pretty soon they find themselves completely encased in bone matrix. What they've built is a lacuna. That's the little house that the osteocyte lives in. And so now you can see where this is going, right? So now once they've built this house, they are no longer osteoblasts, but they become osteocytes. Okay. So now they've got this little room, the lacuna they live in, and there's little tiny little gaps in the bone matrix, the lamella and the canaliculi, that allow just liquid. No cells can go through there, no red blood cells or anything, but liquid can get through there so that there's nourishment getting to the osteocytes. Good? Okay, so that's the idea. So that's what's happening here. So it's good to kind of put this all together. I don't know if the notes did that very well. So we get an idea of these microscopic structure of bone and how it relates to these cells. That's really good. Now they're under the influence of hormones. So there's two major hormones, calcitonin and parathormone. See, calcitonin stimulates the activity of osteoblasts. What it's really doing is it's reacting to the calcium levels in your bloodstream. See, when your calcium levels get too high because you just ate something that has a lot of calcium in it, then your body secretes, and we'll learn in the endocrine system where it comes from and all that, but your body secretes a hormone called calcitonin. And what calcitonin does is it fires up the osteoblasts, because what they're doing is they're taking calcium from the bloodstream and they're putting it into the bone, into the matrix of the bone, since calcium's a major thing. So it really isn't about the bone integrity, it's about the calcium in your blood. Pretty interesting. Parathormone does just the opposite. So if our blood calcium levels are too low, this is negative feedback now, right? So our parathyroid gland puts in parathyroid hormone, parathormone, and what it does is it kicks the osteoclasts into gear. Now the osteoclasts start eroding bone. Well, what are they doing really? They're taking the matrix, and as they erode that bone, the calcium goes back in the bloodstream, and that brings the blood calcium level up. So these two cells are under the influence of these hormones. So there's a disease called osteoporosis. You've probably heard about it. Osteopenia is what we call low bone calcium, and if it's low enough to create a risk of fracture, it takes on the disease form that we call osteoporosis. Okay, and basically, osteoporosis results from an imbalance in the activity of these two cells. So if we have more osteoclast activity, then we have osteoblast activity. So we're taking away bone faster than we're building it up. You see what's happening now? Now the calcium level of the bone itself is weakened, and that's what we call osteoporosis, osteopenia. So here's why that would happen. So it is particularly with women, but it does happen with men too. Well, it's the sex hormones, testosterone in men and estrogen in women, that also stimulate osteoblast activity. Remember, they're the builders. So at menopause, women have a dramatic drop in estrogen. And that dramatic drop results in a dramatic reduction in osteoblast activity. But it doesn't do anything to the osteoclasts. See, so the osteoclasts are still chugging away, taking away bone, but the osteoblasts aren't replacing it as fast. And so we end up with a gradual loss in bone density, we call that, because it's the calcium that gives it its density, its whiteness on an x-ray. And that's osteoporosis. So there's different treatments for it. One would be to stimulate the osteoblasts. So that was a treatment they used to use a lot, but they don't use it so much. They would give women estrogen. And they still do it, but not very much, because there's a high risk of cancer, especially breast cancer, when you take estrogen. So, you know, fracture a bone or have cancer, yikes, right? So they really don't like to use estrogen replacement therapy very much anymore. They've come out with other drugs now. Fosamax is one of these. And what Fosamax does is it doesn't work on the osteoblasts like estrogen would. It acts on the osteoclasts. So what Fosamax does is it inhibits osteoclast activity. And the idea there is, if we're not resorbing the bone, but even though our blasts are working slower, if we can slow down the resorption to equalize this again, then we've gone back to having equal replacement to what we have when we're taking it away. Okay, so anyways, that's just a few words. Kind of interesting stuff on the basics of bone. Let me just see what else I wanted to mention. Okay, so then the next thing we're going to look at is joints, and how you should organize joints. Okay, so what should you know about them, first of all? First of all, in this class, we don't really need to know every single joint in the body and what it's called, and all the different ligaments and bursa and all that stuff around each joint. That's a kinesiology class or a very high level anatomy class. Okay, so at this point, what I want you to know about joints is their basic anatomy. So when you go through the notes, you'll see in the synovial joints uh, area, that's where I go into most of the anatomy. You should know that there's a synovial cavity and a synovial fluid and what its function is. And, just the real basics, just like what I have in the presentation, just like it says in the objectives. You should, you should know, basically, you should be able to categorize the joints in your body, though. Okay, so any joint in your body, you should be able to say what type of joint it is. So in the joints presentation, you'll see there that it starts out with non-synovial joints like cartilaginous and fibrous joints. What I recommend you do to organize that information is to make a big flow chart for yourself. That's the easiest way to learn it. So what do I mean? So what I mean is what a flow chart would look like would be, start out with just joints up here and then go to like fibrous joints, cartilaginous joints, and synovial joints. Now, most of the joints in your body are going to be synovial. That's like everything you think of as a joint. But these are important too, like sutures in your skull, right? They don't really move, but they're still joining bones together. A suture would be a type of fibrous joint. So put those under here, all the different types of fibrous joints, and then put an example. Make sure you give examples. And I give examples in the presentation, but take it from the presentation and organize it like this. Do your cartilaginous joints same way. What are the names of the different types of cartilaginous joints, and give an example of each. And then do all the synovial joint types. Those are like ball and socket, gliding joints, pivot joints, all these kinds of things. They all have certain things in common, but those are the movable joints that we think of when we think of joints. So like a hinge joint, yeah, your elbow. You should be able to say that. Your knee, hinge joint. Okay. Condyloid joints. What's that? Condyloid. Well, you have condyle here in your jaw because it can move in more than one way. It can slide forward and back, protract and retract, but it can also hinge up and down like flex and extend. See, it moves in more directions, but not as many directions as your shoulder. That's the ball and socket joint. So that's what you ought to be able to do is go through all the joints. You should be able to quiz yourself or have a family member or friend just start rattling off any joint they can think of, and you should be able to categorize it. And if you can't, look it up and figure it out. Because I'm going to ask you for sure to categorize some joints as part of the tests that you have. It'll either be on the final and or on the test that we have next week. Okay, so practice that. Okay, cool. Well, I like to keep these pretty short and to the point and hit the main things that I think that you need some extra help with. Next week, I will talk to you about bones and, kind of like how much detail do we need to go into on these and that kind of stuff. So there is a packet in there that has a bunch of labeling. Again, you could get that going whenever you want. You don't have to wait till next week to do that. That's all for you. That's all for you. You could print it. You could make a copy of it. I think it's a PDF, so I'm not sure how you can work with that PDF. You might have to print it out. Not sure if there's another way. You guys are more tech savvy than me, though. You can figure out if there's a way to be able to edit it and type right on it if you want to. But that's what I love about the lab manual, because there's a lot of things in there that are like color this. Coloring is phenomenal for helping you remember stuff. See, it's all about learning to remember things. In this class, there's so much of that, so much memorizing that you need little things that help with that. And coloring, because you're thinking about it, you're coloring it in, and the whole time it's connecting with a different area of your brain than it would if you were just to read it. Writing also helps connect to different parts of your brain. So when you're studying, don't just read your notes, rewrite them. That will help you so much. So anyway, that's that. Email me if you have questions. Our first test will be not until the 6th, actually, of oh wait, we're past our first test. I forgot when I'm recording this. So never mind about that. The next test for you guys includes just this stuff that we just did here from this week. Okay, so it's only got the things in the week 2 there. So right on. We will get back to it and talk to you again next week.